Hey, hello everyone. This is Brady with Nimble This and the Volpe firm. This is episode 62 of Get Your Tech On, our show on all things DOCSIS. Today, our topic is DOCSIS 4.0, frequency split and extended spectrum. We've got two great guests with us today. First up is John Downey, CMTS technical leader with Cisco Systems. John, welcome back to the show.
Good topic. I'm interested and excited to get into this.
Yes, I am as well. I have a lot to learn on this. Also with us is Jan Eriksson, CTO of Technetics. Jan, great to have you on the show. We're working on getting your image focused in here, which, we're going to put the blame on John Downey because he came really, really late into the show and kind of messed up our video. But Jan, great to have you with us. First time here, can you give us a little bit about where you're broadcasting from, and please give us an intro on yourself?
Yeah, okay. Yeah, thank you. Thank you, Brady and John. Yeah, I am Jan Aris, CTO from Technetics, calling from the Netherlands. I'm in the industry now for 38 years. Always worked for Technetics. It was bought by Technetics. For the cable industry. So it was started with video tech systems and modulators, and later on amplifiers and in-home products, etc. Since 5-6 years, I'm now the CTO and driving the teams to come up with ideas of not what we need now, but especially what we need in a couple of years' time. I think that's why I also like this topic. DOCSIS 4 is not what we have now, but we know that this is where we will grow to.
All right. Yeah, Jan, I'm sorry, I didn't want to interrupt you there.
Maybe it's an idea. I show you what I'm sitting in front of. As there is no ANGA and there is no expo, etc., we have built a virtual exhibition. And in fact, we have a wall to show our products. And maybe I can show you in half a minute what we're doing here. So maybe I will start this. What we are doing here, in fact, is also how we build a network, how we go from our head-end products to our access products, etc. And all these types of products that we do on this wall is we always try to do something extra. That's what we try to develop, where we have modular amplifiers, or we have new type of products that we need in the future to drive OpEx down and to make it more for the future. If I go further on with this, we have also in-home products. We have a lot of different components because we make a lot of those products for the industry in the Netherlands, but also for UK, Belgium, etc. And every country does the same on a different way. That's why we have a lot of different components here. But as you can see, we do from cable up to fiber to the home, a number of products that is all the same driver. How can we make the OpEx of a network lower? How can we drive that down? And in fact, try to help with technology developments, try to help the operators to be more competitive in the network. So maybe this gives a better overview of what we are doing to show you the products that we are developing here.
Excellent. Thank you, Jan. And as we were talking before we started going live, I really like the wall. I like the way that in this sort of new world where we don't have trade shows, that's a fantastic way of just being able to show products, being able to show what you're doing in a new virtual world without trade shows. Yeah. So very nice, very nice.
Okay, thank you. Thank you. Yeah, it is indeed. It's a new time, and with this whole COVID, etc. But what we do now with these virtual exhibitions, that we still try to have one-on-one time with our customers to discuss opportunities, to discuss new ways how to improve the networks.
Yeah, so John, I think the gauntlet's just been thrown down. Next time, I want to see that same type of thing on the wall behind you rather than all the clutter that you currently have.
I will do my presentation from the gym, and then I'll do a workout, a virtual workout. How about that?
Well, it's something. It's got to be something entertaining. So, So I want to thank everyone for joining. It looks like we've got a lot of people watching the show live right now. Please do hit the subscribe button if you like the content, and also hit the notification bell. That gets you notified when we do our live cast. We do these every month. We try to give you guys good technical content. So love the subscribers when you do that. So on to our topic today. DOCSIS 4.0, splits, extended spectrum. I'd like to start off with just kind of giving everyone an update on what is DOCSIS 4.0, maybe what some of the differences are from DOCSIS 3.1 and DOCSIS 4.0. And I'd like to toss that out to you guys first. Maybe Jan, you can give your thoughts on, what are the differences between DOCSIS 4.0 and DOCSIS 3.1, maybe what some of the key differences are, and then after that, John, ask you the same thing.
I think the way how we see it is the DOCSIS 4 opens new opportunities for the cable operator to make the next steps. It's not that it is needed now, but they know that there is a road after DOCSIS 3.1, and the ESD to go to 1.8 duplex DOCSIS. Maybe you go to frequency division duplex. There are different ways of doing this. But all these new developments, in fact, are helping the operator to drive more and more data through the same coax. Because at the end, the working area of the coax is easily this wide, and we are only using this area to go to 1.2 gigahertz. And yes, we can go to 1.8, we can make it bigger. We can go to full duplex or FDD, where we mix the signals much more to be more flexible, more dynamic in the data. But that's all options that DOCSIS 4 will bring us that DOCSIS 3.1 doesn't have.
All right, thanks. So John, we talked about FDD, FDX, lots of alphabet soup. What are your thoughts on DOCSIS 4 versus DOCSIS 3.1?
I was talking to my colleague, Ron Hranick, everyone knows, and he mentioned that ESD, even though that was confused with electrostatic discharge besides extended spectrum DOCSIS. So I think that terminology might be going away anyway, and now it's DOCSIS 4.0 FDD or DOCSIS 4.0 FDX. So we have, and FDD basically means extended spectrum DOCSIS. But let's take a step back and say, well, why would I even look at 1.8 gigahertz? The whole push is for upstream expansion. If I want to expand my upstream because that's where my bottleneck is, then I start eating into my downstream. So the downstream has to be extended. You either have to be more efficient with your downstream spectrum, get rid of MPEG-2 video and go to MPEG-4 video over the top, right? Instead of analog reclamation, we're calling it digital video reclamation. And maybe 1.2 works out well. And maybe 1.2 doesn't require change outs of taps or cable or connectors, whereas 1.8 might require some change out of a lot of stuff. And then once we go to 1.8, the only reason why we're doing 1.8 is because we're trying to go past 204 probably in the upstream. So I think definitely 4.0 is we have to stay one step ahead of fiber to the home, but we always have to look back and say, well, the devil's advocate, at what point is fiber to the home is it economical or make more sense? Is it greenfield? Is it rebuild? So I think, is it requirements of speed? There's obviously a lot of variables in here.
Yeah. So we talked about FDD and FDX, and I just want to make sure everyone in the audience understands what those two terms mean. So FDD, what does that stand for, and what is the difference between FDD and FDX? Because both those terms are in the DOCSIS 4.0 specification. Either you want to take a shot at that? Jan, maybe?
Yeah, sure. Yeah. So what you have in the past, we always had that you have an upstream and you have a downstream signal. And in the middle, you have a crossover area. And as John said, I think when we go to 1.8, what we'll see is the reason we go to 1.8 because we want to increase the capacity of upstream. And because we don't want to eat into downstream, we need to move downstream up to have more area for the upstream. If you go, that's the normal way how we always did the networks. But FDX, in fact, that put the downstream upstream on top of each other. And FDD, where you can put it in between each other. So at FDD, you use one frequency once, while in FDX, you can have the frequency going in both directions, at the same frequency in both directions. So it is not anymore that you have a certain split. They say, okay, everything below a certain frequency will be upstream, and above a certain frequency will be downstream. This can be completely mixed, but it is still that on FDX, you can put them on top of each other, while FDD is between each other. I hope that makes any sense.
I would say that I would add that we've been doing FDD forever, but by saying DOCSIS 4.0 FDD, we're putting a specification on the different upstream downstream splits, right? They're all based on a 96 megahertz increment based on DOCSIS 3.1 OFDMA. So you have a 204, a 300, a 396, a 4 whatever, whatever the 96, 96, 96, all the way up to 684. So that's a huge flexibility in upstream, spectrum, if that's where you're going to go. The problem that occurs in the analysis paralysis is I have to buy outside plant with this diplex filter, either a 204, a 396, a 400, a 5. What am I going to do? When do I do it? How much do I need? How much is it going to cost me? It costs me money to go visit all these sites. Do I have to respace my amplifiers? And that's why we're getting into this topic, right? Right, Jan? I mean, this is why you're developing the stuff you're developing.
Yeah, so I think that's I think one of the, and I have sort of on my computer, I have the full duplex DOCSIS or DOCSIS 4.0 spec, and one of the aspects of that is it pretty much describes the architecture of having just a fiber node, and after that, nothing but passive devices. So DOCSIS 4.0 is kind of premises on the standpoint that we don't have any actives, we don't have any diplex filters. And that is a huge challenge for most operators to deal with that. How do we go from having just this, what we call an RPD, a launch amplifier, and then nothing but taps after that into the cable modems? In a greenfield, John, you mentioned greenfield and just doing nothing but fiber in greenfields, that could be realizable, but there's very few places that we can just cost effectively deploy nothing but a fiber node and passives after that. So I think that's where, Jan, how do you see this playing out? What are other opportunities that we could do in this environment?
Yeah, I think that's the idea of what we have as well, is you want to go deeper. You want to take away the cable network, because at the filters, whatever you do, you know that in the future you have to change them again. And so what we want to achieve, to say, can we build a network that is just a transparent pipe, in fact, from an RPD down to a modem? And when it becomes a transparent pipe, or you can do full duplex DOCSIS, or you can do at least, you have a lot of options that you get extra the moment you remove the filters. And as John just said, it's very difficult to make a selection now, because if you want to go to 300 or to 396 or 492, who knows? That all will depend on what app will be developed. And maybe sometimes in the morning this year you had a split on 492, while in the evening is much more downstream. You wish you had them on 200 megahertz, for instance. And that to create that transparent pipe, we want to remove the filters. And that's why we have developed an amplifier that don't use filters. And that way we can still have a network, but we don't have this constraint of filters in there anymore. And so that's why we still do what you were showing just, Brady, that we have a remote PHY device and a home and a transparent pipe in the middle, but that don't need to be only passive. It only can be active, but only if it is active without filters. And that's why, in fact, we have made this amplifier here. This is our DNA, stands for direction neutral amplifier. And I hope you can see it. Here we have the graph on the screen. And in fact, the blue line, that's the downstream, and the purple line is the upstream. And here is that this is already an amplifier that will go to 1.8 gigahertz. And the upstream will already go to 684, but it amplifies in both directions at the same time. And we don't use filters. So now this can be FDX or whatever we want. This is like an anti-coax product. So in fact, if you have a part of coax and you have such a filter, then overall you have a transparent unity gain connection. And that is what we believe is an opportunity to do better with, to be flexible, to be transparent between the remote PHY and the homes. But you are not limited to that you can drive only one time a signal and maybe connect 50 or 60 homes. Now with these amplifiers, you can do much bigger areas as long as you amplifiers without filters.
So with this concept, we've solved your challenge, John, that you brought up of having diplex filters. That's no longer an issue. What other potentials does that unleash now with not having diplex filters in a plant? John?
For me, I'm a realist and I've been around a long time as well. So if it sounds too good to be true, there's got to be a gotcha, right? There's got to be pros and cons. There's got to be trade-offs, and you have to make compromises. To have no diplex filter, and Brady, working together on amplifiers and diplex filters and oscillations, internal oscillations, that loop that occurs between input and output of an amplifier. The gain can't be more than the total loss, or you're going to have a runaway freight train. And that could be between upstream, downstream loop between a diplex filter. It could be the upstream and the RF choke if you are powering in and out of an amplifier, because there's connectivity between the upstream and the power. So you can create oscillations a lot of different ways. So anyone that designs amplifiers has to take all that into account, port-to-port isolation, return loss, gain and losses, shielding, grounding, everything, right? So one of the things I think Jan will talk about is to achieve this no diplex filter, they have to have very balanced downstream gain and upstream gain. And then the isolation, whatever they're using as a diplex filter, it's probably a directional coupler or some type of technology to keep it separate. So that is my I have to know how much gain I have to work with for my spacing considerations and where I fit this product in. And I think, Jan, you're going to mention also about going forward. I always had concern. I'm an upstream guy, and I'm always concerned about upstream levels, modem levels. DOCSIS 3.1 adds more power, which is great. But when I go above 85 megahertz to 204, and then eventually maybe even higher than that, I'm concerned about aerial black-jacketed cable with sun loading. I'm worried about temperature effects. I'm worried about no upstream AGC. So that has to be weighed in on my decision and how much coax do I have. It's not all underground in the US, that's for sure. There's a lot of aerial cable.
Yeah, and I think this is where you said you probably gave John too much information, and now it's going to get uncomfortable in the.
I didn't expect this question, so I was just fine. No, I can answer that. And I agree with John. I was always the same. I said when it is too good to be true, it's not true. I absolutely agree with that. That is also what I always believe in. But in this case, it is. In this case, we have an amplifier. This is the amplifier how we build this. It's a 20 dB gain downstream amplifier, tilted, so it's an anti-coax. So coax have the higher the frequency, the higher the loss. Here we have the higher the frequency, the higher the gain, and that is upstream and downstream. And that's why you see that those lines, in fact, are on top of each other, because it compensates roughly a 200 meter to, let's say, 600 feet of coax. So if you would connect this to a 600 feet of coax, you would have roughly a 0 dB insertion path. And that is the idea that this product will help us to overcome the distance that we cannot do in the future anymore if we want to go to higher frequencies. Because, for instance, when you have an amplifier like here, you have your coax in the middle, you have an amplifier over there, then normally such a network is calculated for 750 or 860. We had the luxury when we go to 1.2 gigahertz that the hybrids nowadays are much better. And that's why we can increase the levels here to be able to reach the amplifier over there. But If you go to 1.8, we probably need a 15 to 18 dB more signal here. And there is no way we will ever be able to drive that out of a unit like this. So therefore, to have a gain block in here to help us to overcome that loss, so in fact reducing the distance of the coax with 600, 200 meters, in fact, we don't have to breach the long end from one amplifier to the other, and that's why we can go to higher frequencies. Upstream, you're absolutely right. Upstream is exactly the same, because on upstream, it's also, we want to go to higher frequencies. And if we go to higher frequencies, even when we go to 684, the cable loss compared to 42 to 684 is 400% more. So if we had 5 dB loss first, we're going to have 20 dB loss if we go to 684. So you're absolutely right that we're going to need higher levels. And is a modem be able to do this? And those kind of questions is going to ask. And that's why to have that gain on the upstream, roughly around 10 dB on the higher frequencies, helps us, the modem also, that they don't have to travel that hard. They don't have to transmit that high level anymore, because in fact, they get helped here to be able to reach this amplifier here. But what this booster amplifier will do, because this has the gain, is also on the lower frequencies, as you can see, it's only a few dB. But when you go to higher frequencies, you will have more gain. And that's what will help the modems, if they go to higher frequencies, that they don't have to transmit that. Because they, it is upstream is a difficult one. It's absolutely difficult. On downstream you can have AGC. On upstream it's more difficult because DOCSIS, in fact, is not helping. The DOCSIS protocol is not helping to build an upstream agency. So we need to use the information from the downstream agency to create kind of an upstream agency. But that's doable. Those things are possible to work with. And that's why we get a much more stable network. The way how we built this amplifier, in fact, is we use a different type of technology. As you said, we don't use diplex filters, we use a different technology. And that has the beauty of being extremely temperature stable. So we have no temperature drift in such a product. So we have no issues on the upstream on higher temperatures. But of course, we do have the issue of the cables. So that's something that we always will have, and that's why an AGC, maybe in the products around it, or maybe in the future in a product like this, will help us to be sure that we keep a constant level. But for now, what we want to prove is that we can build amplifiers with no diplex filters, and this will open now the opportunity to do something different than we always did before. Because now we built a parent pipe, and now we can do a lot of extra features with the cable network.
So do you think that, or do you see this evolution continuing where we'll have maybe amplifiers that have even more gain without diplex filters in the future?
Yeah, we started this idea 5 years ago, and it was not an easy ride because we had an idea and we failed, and we had another idea and it failed again. So it was absolutely not an easy ride to develop this product. But about 1.5 years ago, we had the right answer, and that worked. And on that moment, we could build couplers of certain performance that we could use inside amplifiers to take out the diplex filters. But in the past, half a year ago, we were talking about amplifiers of 15 dB. But from that moment on, we improved our isolation inside these couplers. And we are now on a level that we can build 20 dB constant. And it is not only, as John said, it's not only that we are worried about the oscillation, it's also worried about return loss. Because at the end, if you look inside this unit here, you have, of course, you're going to have your loop gain inside, and that loop gain has to be lower than the return loss. Otherwise, it has an effect on your return loss on your input as well. So it's not that the loop gain has to be lower than 1, no. The loop gain has to be lower than -20. Otherwise, you will see this on your return loss as well. And that is what we have achieved now with this special couplers. And but I'm sure that in the future we will improve these more, and then we can work to amplifiers maybe of 25 or even to 30 dB.
What about because I remember when FDX was full bore going ahead, and push for echo cancellation. Because I was thinking of the same idea. If I can get rid of the diplex filter, well, the problem with diplex filters also is the 23 to 25% no man's land of a diplex filter. So as you get higher and higher up on a diplex filter, a 684, the downstream starts at like 750 because the diplex filter region has to be so big. A 4254 is small, right? An 85 108 a little bit bigger. A 204 254 even bigger. So yeah, as a diplex filter, it gets wider and wider so you don't bleed over. That's the problem with regular diplex filters, and echo cancellation got rid of that. So I'm wondering, even with your technology, could we make a higher gain amplifier with echo cancellation? Or is that just too much power, complexity, trademarks? I don't know, copyrights. I don't know who owns it.
No, you're absolutely right, John. Now, yes, echo cancellers help, absolutely. Echo cancelers will be able to give you more isolation, and therefore, at the end, you can have more gain. Because the higher the isolation you have in your couplers, the higher the gain you can achieve with such a product. As I said, it is the gain minus the isolation still has to be at least minus 20 dB, otherwise you have an effective return loss. Yeah. So if we can use echo cancelers to improve that, then we can go higher in gain. The downside of an echo canceller is that we still have to measure it and we still have to combine it in a way that overall we lose another couple of dBs of gain again in our echo canceller. But if we can do that right, I believe we can do this. We can build higher gain amplifiers. But also in that case, the power consumption will go up, because the power consumption of this device is only 5 watts. So it don't even get warm. It's a product that you put in your network and you don't even see. If we start to add echo cancelers on the in and the output, we directly add about 15 watt power. So it doesn't fit anymore in such a housing. And also when you look to such a product, because it don't get warm and all these things, the reliability of such an amplifier is much higher than the reliability of a normal amplifier, because that, of course, you have the temperature, you have your capacitors, you have your hybrids, etc. And in here, we only use mimics. We don't use hybrids. And mimics, of course, are much more reliable than hybrids already. That is 15, 20 years lifetime of a hybrid, but this is easily 3, 4, 5 times that much. And that, of course, helps us by keeping the temperature down. Because the moment we put in things like echo cancelers, it becomes a different product. This idea was to help in the original idea was that we have a mid-span amplifier to help the signal to travel the coax to reach the next amplifier. If say, okay, if it is what Brady you showed, that we have an RPD and we have taps and we have homes, then we don't have those amplifiers anymore. Then we start to talk about distributed gain, because we're going to have a few of those small amplifiers in a line. Yeah, and then power consumption absolutely becomes it becomes important, because at the end it all adds up. So if we have 5 watt here and we have to put 2 or 3, then you talk, of course, about the 10 or 15 watts on power consumption. Still much lower than a normal amplifier. Huh?
Yeah, I was going to say that's really low power. This is almost like the LED of power consumption in the cable industry.
We should call it green.
It's green, yeah. It's green power consumption. No, that's really very good. And I just want to mention for our listeners who maybe don't know what a hybrid amplifier is versus a mimic amplifier. These are like the hybrid amplifier block is the standard gain block that is in a big amplifier chassis or a node. And normally there's 2 hybrid stages in an RF amplifier, like a trunk amplifier, bridger amplifier. That's typical of what you'd expect, but they normally consume quite a bit of power. Nowhere near what we're talking about, 15 watts. I think a hybrid amplifier alone consumes maybe 8 or 10 watts. You may check me on that and tell me if I'm correct. But so using the mimic technology, this is just small silicon components compared to a large block amplifier in a hybrid, correct, Jan?
No, you're absolutely right. And a line extender is easily between 20 and 35 watts.
Right.
And you talk here, of course, this is 20 dB gain, while a line extender has 44 dB gain most of the time. So you need to compare to the 20 to 35 watts what you otherwise have. So you are always around half or more lower in power, if you look to that. So you have a much lower power consumption, and of course you have the beauty of that you have that in here you have no filters. And what is extra with this is, what I really believe is a great feature, is that we don't have to travel that high. Because overall, if we have two of those amplifiers compared to one line extender, because a line extender always make the signal go high, and then it will go low on the network again and go high. And the two problem areas is always here you have the intermodulation, and here you have the noise. But now you stay out of that, because you stay out of the intermodulation, the noise, because you don't go that high, because in fact you now have more smaller steps, and therefore we don't come in the noise, and we don't come in the a much higher quality to deliver into the home, and therefore you can have a higher modulation scheme, you can have more data in there, etc. So by going distributed gain with smaller amplifiers, your power consumption will be half or less, and the other side is that your performance, your quality effect will go up. And there's still some development to do in this area, but this absolutely opens the door for DOCSIS 4, because this opens the door for all the DOCSIS 4 specifications. We talk about FDD or FDX or ESD. For these products, it doesn't matter. It doesn't matter what you put on, because if it is FDX or it is ESD or FDD, it doesn't matter because it's just a transparent pipe.
So is a concept behind distributed gain that we would have many of these small types of amplifiers, these kind of booster amplifiers throughout the entire cascade, rather and no amplifiers, no traditional type amplifiers, but we're going to have many of these, and that's how we'll amplify the network. Is that the overall concept?
Yeah, that's the idea. So instead of that you go higher signal and then go low and go high again, in fact, we just keep the signal in the middle. So it is like a meal on a day. Hey, you have 2 big meals, or do you want to have 7 or 8 meals over the day? You have to keep the engine going. So,
I like that. Yeah, and I think nutritionalists would support you on that.
It depends on what's in your meal.
Yeah, I try to be polite. Normally I use beer, but I thought the guy would use milk.
So John, your thoughts on this?
So I think it's a good lead into one. What is the terminology now? DGA, distributed gain architecture, right?
Correct.
Perfect. You're taking the gain, distributing further apart instead of putting it in one big block. And I understand that makes sense. The other point would be, I'm always going to go back and forth. The booster amp idea, like behind you right there, the booster amp idea, I think makes sense if we need to go to 1.8 or because we're going to increase the upstream. Where I have and I think I see where things could play for me would be once I go to 204, I'm going to do distributed access architecture. I'm going to do fiber, digital fiber. I'm getting rid of my analog link because laser clipping 204 upstream, just don't see it really working well.
It's not going to happen.
So 204 and above upstream, I'm going to have remote PHY or remote MAC PHY or some variant of that. I'm going to run fiber pretty deep. I might have an existing N+4 architecture, which doesn't bode well for FDX, which is why we're here. So N+4 for amplifiers, I don't want to respace, but I might have to drop in the booster amp. Now, the great idea of no diplex filter is great for that booster amp, but I still have the existing amplifiers that are in between. I can't rip those out and put in your technology at that point. Maybe, maybe not. It depends on the architecture, right?
No, correct. No, that's correct. If you have an N+4 network, and at the end, what this is all in the toolbox. This will help you to overcome the length of the coax if you want to go to a higher frequency, to new service. But it's exactly as you said, you have temperature drift, you have different things, and therefore you need ALSC, you need AGC inside your network to keep you stable, etc. That's this product. This product is to boost the signal to be able that one amplifier can reach the next amplifier. That is how this will do. And exactly as you said, if you want to go to 1.2 gigahertz and your network was developed as a 600 megahertz network, then maybe you are struggling because you need too much gain in the amplifiers. And by instead of increasing the gain here with 3 dB, you have to go to double power consumption of the hybrids. And at the end, you are building yourself a huge risk factor in your network because all the energy will go to one product, one thing in the network. And now by distributing this or by putting a device in the middle helps your whole network. We did a test with this where we had an amplifier like here and we had an amplifier over there. And we aligned the network with the long coax and we measured the quality on the end. Then we put this extra booster amplifier in and we did the same test. And we want to see how much is my quality decreasing on the end of my last amplifier. So we expect, because we add a gain block, that the quality in fact should go down. But the result was that the quality went up. It went up even 6 dB MER. And that was because I am staying out of the intermod here and I'm staying out of the noise there. And this is what can help you to do a new thing for your network. And that's what I said. You don't need this everywhere. You can need this maybe when you have a long cable, when you have a feature, when you have an N+4, and maybe say, okay, I have some areas with small cables, some area with bigger cables. Then with these big cables, to reach space. You keep them on the same place. But you're absolutely right. You still have your diplex filters in those big amplifiers. That's how it is. And if you say, I want to take those amplifiers out, or those diplex filters out, it becomes a different story. Then you need a lot of those smaller amplifiers to put in line. And then you still need to think about, okay, what do I do with ALSC or AGC or things like that? But if you have an N+2 network, it becomes a different story. Because with N+2, and then normally the cables are not that far, then maybe instead of putting 2 big amplifiers in there to create 88 dB gain, and now suddenly you can build a network with no diplex filters. Now you have a transparent pipe. So I think it all depends on the situation where you're in. If I look to the network that Brady just showed, where you have your RPD and you have your taps and your homes, this can connect more homes. Because you are just gaining the signal to have more and more taps in there. But you don't lose the part that you say that you have to put filters in. So now you still can do full duplex or every split you want to do. Area. Because as you said, if you go to 684, the crossover area will be somewhere between 120 and 180 megahertz. So that is a very good frequency area that you in fact throw away by using filters. By using this, you don't have those filters anymore. And that's why you can go to 684, you can stop your upstream, and your downstream can start the 684, because you have no filters anymore. And that is what helps you also in your distribution side. But I absolutely agree with you, John. If you say I have an N+4, can I replace an N+4 for only these amplifiers? Then we need to build an ALSC or an AGC or something like that inside this type of amplifiers. Or maybe we have to come up with an idea that we can use those couplers inside those devices to remove the diplex filters also from the bigger devices.
Yeah, that's where I'd like to see it go. And those bigger devices, because they were spaced, because of passive loss and coax loss, they might need to be the same gain they are today, which means higher gain than your low gain amplifier. And maybe they would have to incorporate echo cancellation. I don't know. When we start factoring in operational expense, OPEX, of putting a man on the pole, not on the moon, but on a pole, and respacing amplifiers and cutting cable and putting connectors on, then at some point someone's gonna say, why don't we just run fiber? You know, if I have to redo all that, why don't we just run fiber and be done with it? And I agree, fiber as far as I can go makes sense, but it's still economics, right? Fiber to the home is pretty darn expensive, and return on investment could take years.
I agree. And why would you? Because at the end, you have a very good coax cable. Yes. By just using this more smart, what we try to do in this way, we don't have to fiber to the home, because you, as I said, that whole area of the coax, we're only using a small part of it. And by using more area of that the coax is, yeah, we can just do more.
Do you have any, I don't know if it changes the fundamentals of your amplifier, but do you have any plans, or can you make the gain of your amplifier flat? Like, what if I don't want a tilted gain? Because you're basically putting an equalization inside. What if my design, I just want to, I'll do the equalization at the next amplifier. Why? You're forcing me into a design with your tilted gain. So for instance, if you tell me there's 10 dB gain on the upstream at 684, but there's only 4 or 5 dB gain at 12 megahertz, that means I only have 4 or 5 dB of passive loss I can take care of.
Yep.
You understand?
Yeah, no, not that easy. The reason, the way how we build this is in a way that the original plan was that you have an amplifier. Now you put this in, and that amplifier in the middle helps you with the additional tilt. The beauty of that is that at the end we can, from our first amplifier, we don't have to drive that high tilt and that high level, because now we can in fact flatten this, and therefore we also can increase the lower end. We can decrease the high end. That's why we don't need to put all those cable simulators anymore in our taps, etc. We can take all of these things out, because at the end, a cable simulator is nothing more than resistors where we burn signals. And that's a pity, because we just paid money to create the signal, and now we pay money to burn it again in resistors. So by just having less tilt out of our amplifiers, by dropping the high end and increasing the low end, we take it more out of the noise, we take it out of the intermodulation. The whole quality of the amplifier becomes better, and halfway the line we get helped. And that's why we have a higher level going through the signal to the network, and that's why we, at the end, we can use higher tap values, and that's why we can have lower insertion loss from in to out. So all these things in fact starts to help us. By putting a small booster in with that it's tilted, helps us on that we can go for higher taps, less loss in our passives, and we have a lower high end and a higher low end on the amplifiers, wherefore the TCP will be lower, you have less intermodulation, etc., etc. So overall, these things are all helping us by, in fact, reducing your cable network with 600 feet of coax. That's what you do.
So I'm fully aware of that aspect of it. My real question to you was, if someone goes to you and says, hey, can you build me a flat gain amplifier so I can use it in certain parts of my architecture, can you do it, or does that affect my return loss and oscillation?
Yeah, it will affect it. It will affect it. We can do it, but we cannot make a flat amplifier of 20 dB. And maybe overall we have an amplifier of maybe 7 or 8 dB flat. We can do that, but we cannot go for a 20 dB flat amplifier. No, that's not in the design.
And I'd be more on the side of the upstream. I'd rather have as much gain on the upstream as I can. Downstream, yeah. I agree. Downstream, I agree.
But we can increase, yeah. What we do now is put the upstream on top of the downstream, because we want to compensate 600 feet of coax. And the loss from left to right is the same as from right to left. And that's why we created that line, that downstream and upstream are on the top of each other. If we have a customer say, I wish I had 3-4 dB more gain upstream, that's something we can do. We can create more upstream gain. And we can say, okay, this purple line should go up maybe with 3 dB to help me with my network, that my modems can transmit a lower level. That's something we can work with. The reason we don't want to have too much gain on the low frequencies is in fact that at the end, our modems will transmit a lower level, but my noise floor will move. So in fact, my carry to noise out of the houses will be worse if I give too much gain. And that's why we're balancing this. We try to have a few dB gain to help us by balancing the network, but we don't want to give so much gain that in fact the transmit level of the modem will be too low and has an impact on our. Of course. At the end, that will be a decision of the operator, of course, how they would like to have that part. If they want to have a couple of dBs more gain on the upstream, we can do that. That's not a problem. But as I said, it will have an effect on your carry to noise.
Okay.
Do, of course, fall in the same bell curve, that all the upstreams in your network, in fact, are roughly the same transmit levels, and that's why all the noise floor roughly are on the same level.
Yeah, the one concern, well, the concern I had with the upstream was in the U.S. You say we have an N+4, but an N+4 could easily be 20 actives off the node, right? Because we branch off everywhere. So if I have an amplifier that feeds another amplifier, but there's a splitter in between, that splitter at 684 could easily be over 4 dB of loss. It's not going to be 3.01 dB of theory, right? It's not going to be 3.5 that most people would say, but at 684, it's probably going to be 4.5 maybe. So there's 4 dB of passive loss I have to compensate for with my gain.
Yeah,
somehow.
Understand. So that's why our next products, what we are doing is to build this technology inside splitters, inside our passives, to compensate that loss. Because I agree with you,
Brilliant.
If you have an 4 dB or a DC or whatsoever, that you have a flat loss, you wish you could compensate that. That's something that we are working on in the next generation. So you're right about that part. So that's why we are thinking of building, in fact, active passive components, and those components then will be lossless. You have a lossless splitter in the network or something like that. That's something that we will build inside those units. Yes.
Very good. That's why I think it's very important for us in the industry to have these conversations now, right?
Yeah. No, I absolutely agree. I love this conversation, and that is so now we have solved the problem of the coupler, and now this is a very it's stable. We tested this over temperature. We tested over multiple things, and we have a good performance out of those couplers, consistent performance out of the couplers. It also gives us now the option to do more and more things outside the existing booster amplifier. Yeah. And maybe, as I said, maybe where we have active passives or direction couplers or things, something like that.
Yeah. So in the chat room just called it lossless passives, which and I think they could be gain passives. So I like that concept.
Yeah.
So we only have about 5 minutes left, and I'd like to just kind of change the topic just a little bit to sort of look towards the future. And everyone's kind of asking, when is DOCSIS 4.0 going to be available? When are DOCSIS 4.0 modems going to be available? Which I know we don't know that, but I'd like to kind of ask each one of you guys what your thoughts are. When do you think, if you have any concept or any thoughts, when do we think we'll start to see DOCSIS 4.0 actually coming to fruition? And John, I'm going to toss this to you first. What are your thoughts on DOCSIS 4.0? Whether it's just FDD or FDX, doesn't matter either way. But
I think luckily we still have runway with DOCSIS 3.1. Mm-hmm. We can definitely go a lot further with DOCSIS 3.1. The CPE are already available for 204 megahertz upstream. The limitation here would be 2 OFDM blocks, 2 OFDMA blocks in the CPE, right? But that still gives me 3-4 gigabit per second on the downstream, corresponding with, say, 32 single pair QAM. And the upstream, if I go to 204 and I do 2 OFDMA blocks, I can offer a 1 gig service. That right now has been like the panacea, the holy grail, is how do I offer 1 gig service? I can do that with DOCSIS 3.1. I can do that with a 204. When we look at DOCSIS 4.0 and the CPE, the fact that people are getting into it, not getting into it, someone's buying someone else. I don't know who owns the silicon here or there, and who's actually developing. I would say a year, maybe more than a year.
Yeah.
And it might be supply and demand. There's no real demand because 3.1 has a lot of runway, right? So FDX kind of started losing its thrill when they said, oh, you need to do N+0. That ain't going to happen. They would say, well, maybe we do N+1 with an echo cancellation or in a line extender. Yeah, but now I have to redesign that as well. It's like, and that's why we're here. I said, well, we still need N+4. We need amplification with a diplex filter that can be changeable. So if it's no diplex filter, great. If it turns out to be a compromise between Technetics' solution and existing higher gain amplifiers with a diplex filter, that might be acceptable as well. I might see myself with a booster amp and this lossless passive and the existing spaced amplifiers that you change out the module, but it has a pluggable diplex filter. And maybe that's okay. Because even though we're losing space in a diplex filter, if I go to 1.8, I might say, yeah, I can afford to lose some space in a diplex filter. I'm going to 1.8, so who cares? You know?
More bandwidth.
Yeah. But to go to 1.8, the only thing that can use from 1.1 gig to 1.8 is DOCSIS 3.1.
Yep.
DOCSIS 3.0 ends at 999. So I definitely need, more OFDM, OFDMA. And then the CPE have to support more blocks if I want to, offer higher speed. And I don't know what that speed means. The speed means Cable Labs mantra of 10 gig, right? That was our saying is 10 gig. That's where we're trying to get to is 10 gig. I don't know if that meant 10 gig per home.
I think it's a pipe, a 10 gig pipe share.
10 gig.
Jan, your thoughts? Same question?
I agree with. But in fact, John says at the end, I think it will come down to the silicon. It is not as much as to the network because we know there are opportunities to do the network. We know how we can make the 1.8 gigahertz network. In fact, we already have products that go up to 4 gigahertz. So I'm not worried about that area. And there will be new products that help us without diplex filters like this product or maybe different products. At the end, what we try to achieve is to have the best possible quality into the home. But how it is dealt with in the home, of course, that is where at the moment the bottleneck is. Because there were probably 4, 5, 6 years ago, everybody thought, oh, we go to full duplex DOCSIS. Then we get the extended spectrum DOCSIS group, and suddenly a lot of people move into that area. And now we have 2 areas. One is in full duplex, and one is in 1.8 gigahertz. And at the end, that doesn't make life easy for silicon. Because how do they play that game? And do they put all the eggs in the basket for FDX, or do they go ESD, or do they do both? That of course isn't something that is holding them back, because whatever they do, they have only half the market, because half the market will go a different way than the other one, and that is at the moment makes it more difficult. But the beauty is that, as I said, I know there are creative solutions where they go for special tilt and zigzag tilt and things like that. At the end, I don't think that what will make it is that we want to drive the best possible quality in the home. And products like this will help you to steer up that you can have 4K QAM even up to 1.8 gigahertz into the home. And when you have that signal there, then it is up to the silicon how to deal with it. I still believe that DOCSIS 4 is a few. And that is just because the signal is not there. And I also don't think the market is there, because it goes the same. We have to be careful that we don't go the same route as we had on remote PHY. That 5 years ago, everybody thought, oh, remote PHY, this is it. Let's go for it. But besides a lot of trials and a few customers that start to roll this out, still not a lot is happening. And now everybody waits for the second generation. And that of course, people are worried that they will develop the wrong products, and that's holding back the development of those silicons.
No, it's a very good point. Very good point indeed. So, gentlemen, it's amazing. We've covered an hour, and it's gone by so quickly. I want to give you each an opportunity. If there's anything you want to plug that's coming up, John, anything coming up you want to plug?
2 papers and presentations for SCT Expo Virtual. One is the power of DAA, so distributed access architectures. The fact when you go digital fiber, there's no laser clipping and much better performance and more complementary DOCSIS 3.1 higher modulation schemes upstream and downstream. So I go into that on the power of DAA, and also got accepted for the track is all based on COVID-19 pandemic and capacity that was increased over a 2-week period for 1 year of capacity over 2 weeks. And, the CAGR and, compound annual growth rate that occurred in 1 month. So I talk about capacity concerns and mitigation of congestion. How do I mitigate congestion and deal with it? So I have a presentation and paper on that. And those are, that's Expo is supposed to be October. So I think our workshops are still going to be live. So I already got a date of October 14th. 9:30 for one, I think 1:30 for the other one. So I'm doing 2 presentations that day. I thought they would have us just record them and it would be in some type of, I don't know, depository or something.
Yeah, they're going to be streamed live and recorded.
Okay. Yeah, I was surprised. And to me, you know how I like to talk. I wanted to be able to record my own for like an hour, but they're putting me on a workshop with 2 other guys, so I'll probably.
You're going to get 15 minutes, John.
I know. I will never get more.
Sorry, buddy. Jan, anything you want to plug?
No, it's more that I will thank you for your time that we could show our products. That's what we do here. As you could see, we are this virtual exhibition. So if people are watching and they would love to see more about our products, I hope that you contact us, and then I'm sure we can work this out. Because we try to do this interactive, that we can have the discussion about the products, etc. So we don't want to send a video, but really want to have a discussion to see where the opportunities are for you and for us. So thank you for your opportunity.
I want to thank you, Jan Eriksson, CTO of Technetics. This was a fantastic show. And John Downey, CMTS Technical Leader at Cisco Systems. Also, thank you very much. Fantastic show. This show will be available on YouTube for anyone to to watch the recording of this as well. And we'll also make an audio podcast available for anyone to download and listen to this on your favorite podcatcher. So again, thanks so much for everyone watching. There was a great discussion in the chat room, and I also want to give special thanks to Diego Royo. I hope I'm saying your name correctly. Diego, you did a great job moderating the chat room because there was a lot of questions going on. Special thanks to you on that, and I know you also had something to do with that fantastic wall at Technetics. So thanks again on that. Thanks, everyone. Great show. Have a great week, all. So long.
All right.
Thank you. Okay.
Thank you. Bye-bye.
Bye.
See ya.